It's a phenomenon in the brain that we often call plasticity, or the ability to remake, rewire, repurpose the brain so that it can process different types of information.
This is SIFT.
Each episode we tackle a topic and talk to experts who have bumped into this topic regularly from around the world. On the show today, we'll hear from Professor of Speech-Language Pathology and Neuroscience and Education at Columbia University.
I'm Karen Froud, and I'm the Director of the Neurocognition of Language Lab.
An electrical engineer and Professor of Neuroscience at Maryland.
So my name is Shihab Sharma.
And we'll start with Professor Sharma. His experiment is really cool. It started with this idea that you could take the auditory cortex and have it process visual information.
So basically,
which is really weird.
It's remarkable that if you take a really baby ferret, tiny newborn ferret, and you leave the auditory cortex intact, but knock out the inputs to it, so all the nuclei below, just put a little cut in there so that no auditory input goes to the auditory cortex, and then instead take the optic nerve,
just getting visual information from the eyes,
and put it right next to the input to the auditory area.
Wait, how do you do that? How do you?
Surgically.
Oh, really? So you go in there and you actually pick up a neuron and just kind of push it over. Oh, wow.
That's right, exactly. So people have done all kinds of manipulations like that in lower animals and in ferrets and other things. And what you see is that when the animal becomes an adult, the auditory areas which would have responded to sound and tonotopically, organized according to frequency, XYZ, all of a sudden start responding to light as if they are the visual areas normally would respond.
Wow.
It was underdeveloped. Like a dominant
In fact, Sharma even mapped how the auditory cortex, the hearing part of your brain, was processing the visual information.
Yeah.
For instance, the neurons in the auditory cortex that normally handle the range of frequencies being fed to them are now processing something different.
Happens all the time.
They're being
They're just
fed
not really
visual
trained
information
to
from the
utilize
retina.
it.
Exactly.
It just turns out that the old frequency information that they were processing...
This is like hitting your retina from left to right. So you map, basically, frequency information to a little space on your retina.
But this isn't the only visual information that these auditory neurons can handle.
You map pitch to symmetry, okay? You map timbre. Timbre is the quality of sound. Turns out it maps to form of an image, okay? Using two eyes and using two ears, they are basically the same kind of information. They look at the differences between the signals coming to the left and right eye and the left and right ear. In the ear, it gives us information about where the sound is coming from in space.
Both
and in the eye, it gives us information about where it's coming in space, but in that third dimension, what we call the stereopsis, or depth. So we map auditory space to depth. Edges are edges, whether it's edges of an image or edges of a particular energy in the sound.
That absolutely has to be true, because, when someone hears themselves falling, then they immediately see where to put their feet
next. The beginning of a sound, the point at which a sound transforms from one to another.
And so on. So that's how you basically try to create from an image, a visual image, a sound.
Which is totally possible. Totally possible.
That tells you that the principles underlying the processing of sensory information, there is a huge amount that is basically conceptually